Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
So hello everyone, very good evening to everyone out here. So can I please have a +1 in the chat box, those who are watching me right now, and so that I could get to know your names, and then we can very quickly start. Apology, I started the stream 15 minutes late. There was a small network issue from my end. Okay, so hello Rishit, how are you? Welcome once again. And just like Rishit, I would request everyone, all of you, to kindly do a +1 in the chat so that I could get to know your names. Okay, so that's very well. Let us start then. Give me a minute. Okay. Yeah, so today also we will be continuing with our discussion on recursion and backtracking. Okay, and if you remember, we studied in the very first session, we studied about subset sum 1 and 2. Then we studied about combination sum 1 and 2. In fact, we discussed the suboptimal approach of combination sum 2 yesterday. Okay, so I will be discussing palindrome partitioning today. Okay, the important topic for today is palindrome partitioning. Okay, so let me give you a small introduction about this series. So this series is called Practice Session on SDE Interviews. So what basically happens here is that every week I pick up a problem, pick up a topic. For example, we are having recursion and backtracking this week, and we discuss important concepts and important questions related to that particular topic, which are relevant from interview point of view. Okay, so, and apart from that, we also have something called complete interview preparation. You will find the link in the chat box. It is pinned in the very first comment itself. And apart from that, we also like you can check that course out. It is an extremely well crafted course if you are preparing for your interviews. Okay. So yeah, let us wait for a couple more minutes for others to join, and then we can very quickly start. Okay. So hello, Pranjal. So Pranjal, are you in your you are in which year of your college presently? So it would be really helpful if you all could write the year of your college you are presently in, and whether are you preparing for your interviews or not. Okay, so let me share the Microsoft whiteboard, and then we can very quickly start. Okay, Pranjal, that's very great. You're in your third year. In fact, I am also in my third year presently, and yeah. So Pranjal, you will be having your placements upcoming, or are you, uh, or will you be having your internship pursuing engineering and information technology? That's great, Pranjal. Okay, yeah. So let me give you a small introduction about myself, and then we can start. So my name is Gaurav Kumar Shaw, and I am presently in my third year of BTech at IIT Kharagpur. And apart from that, I am a mentor at GeeksforGeeks, and presently I have been, and I am also an incoming software engineering intern at Curefin. So I have a vast experience of mentoring and teaching data structures and algorithms to students. And I would request you all to kindly stay till the very end in the session, and you will definitely enjoy this session. Okay. So it's a humble request from my end. So let me start with the. I hope black works best. Okay. Okay, so let's see. Let's make it three. Okay, yeah, this works best, I suppose. Hmm. Okay, so yeah. In fact, Rishit and Pranjal, Rishit, since you're appearing, since you're coming in this sessions for a very long time on a regular basis, why don't you invite your other friends to join our session as well? Okay, so yeah, so those who are watching, I would request you all to kindly invite your other friends as well, college friends, friends, or your class friends to appear in these sessions. And this session won't be very long; it will be around 40 minutes max. So, and a very important concept we will discuss today. So we will be discussing something called as palindrome partitioning. So do you know about palindrome partitioning, Rishit? Do you know about this palindrome partitioning? If you know about this, please do a +1 in the chat box. That will be very good. Okay, Pranjal. Hello, Pranjal. Do you know about palindrome partitioning problem? Hello, Rishit. Hello, Pranjal. It's entirely okay if you do not know about it. I'm here to discuss the approach, and it will most certainly be helpful to you all. Okay, so we will be discussing palindrome partitioning problem today. So let me write the problem statement for you all to understand. And before I start writing the problem statement, let me just decrease the size of this pencil because it's becoming quite. Okay, so yeah. So the problem statement says that let's say you are given a string S. Okay, so S is a string. Okay, the first thing. Second, you have to. The question is asking you to partition this string. For example, if I write geeks, let's say geeks is a string. Now you can partition the string by placing a partition here, or let's say here. Okay, so this has basically been partitioned into three different types of string. Okay, and in fact, since you are partitioning it here, we can say that this is also an empty string here as well. Okay, so the idea is that you are putting places. You are basically partitioning the given strings. Now the question is asking you to partition the string in such a way such that every partition results in a palindrome. Okay, such that every partition is a palindrome. Okay, it means that since I have partitioned this should be a palindrome, this should also be a palindrome, this should also be a palindrome. In fact, we see that G is a palindrome, double E is a palindrome, but KS is not a palindrome. So this will not be a optimal palindrome partitioning. Okay. So the question is asking us to given a string A, and we have to partition it into such a manner such that all partitions are palindrome in nature. This is the first thing. The second thing is that each subarray is a palindrome. Yeah, it is a similar problem, but the question is asking us to return all possible palindrome strings as well. Okay. Now, what do you have to return? Okay, let's see what you have to return. So let's say if your given string is an example AAB, so I can partition the string in this fashion. Let's say I call the first alphabet as A, the second A, and the third B. So all these three are palindrome part. Okay. Now I can also write something like this: A and B. Okay. So this is a valid partition. So this part. Okay, because I can this has been formed by partitioning it like this: AAB. So AAB. Okay, I have got A, I have got A, I have got B, and AAB have been formed by partitioning it here and here. So this is a palindrome and this is a palindrome. Okay, so you have to return all possible palindromic partition in the form of vector of a vector. Okay, so this is a vector which contains various strings. This is a vector which contains various strings. Okay, so for example, let us look into a simple another problem. Okay, so let us have a look into another test case. For example, if you are given AABB, so in that case, you can there are various ways to partition. So let's say you partition it just like this: AABB. Okay, so in this case, we have got this is a palindrome, this is a palindrome, this is a palindrome, and this is also a palindrome. We can also participate in something like this, partition in something like this: A, B, and B. So this is a palindrome, this is a palindrome. Then again, we can partition something like this: A, B, B. Okay, so this is a palindrome, this is a palindrome, this is also a palindrome. Okay, and finally, we can do something like this: A, B, and B. Okay, so this is a palindrome, this is a palindrome, and this is a palindrome. So our answer will look something like this: A, 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 B, A, B, B. Then we will have A, B, B. Then again we will have A, A, B, B. Okay. So in fact we have got four different types of vectors: one, two, three, four. So there are four different ways we can partition our string such that the resulting partition is in such a way that each partition is making a palindrome in itself. Okay, so this is how this will progress. So any ideas how we will solve this question? Pranjal, Rishit, can you tell me how we will solve this question? Any ideas, anyone? Okay, so I will request all of you, those who have joined the session right now, to kindly do a +1 in the chat box so that I could get to know your names, and at the same time, it will keep the session interactive as well. So, and also we have a course called Complete Interview Preparation, and in fact, if you are preparing for your interviews, you can definitely check that course out. So, it will most certainly be very helpful for your interview preparation. Okay. Can we try dividing the remaining string at each point and check if the string is a palindrome or not? Dividing the remaining string at each point and check if it is a palindrome or not. Yes, we will be doing it. Exactly this. Okay, but there is one small technicality is here, is that we have to generate all possible first of all. Okay, and the second here is that we have to make sure that since we are partitioning the string, we have to make sure that each component of the partition is palindrome in itself. Okay, so yeah, since you all have already guessed that since we are having a topic of recursion and backtracking, this will require recursion. Okay, so how will this require recursion? Let's see. Okay, so let us say that let me write a recursion tree first of all. Okay, how is this idea coming up? Okay, so let's say our string is AABB. Okay, so we want to apply some sort of recursion here. Okay, so let's say I am standing on this index. Okay, now what I do, I put a partition here, which means I put a partition here, AABB. Now I am able to put a partition here because this is a palindrome. So I am very much sure that this is a palindrome. So that's very good. Now I will recursively call for this part of the function AABB, and I would like to know that if I am putting a partition here, whether it is possible to further partition the remaining string in such a way that this forms a palindrome. Okay. Now I again recursively call for the statement, and I put another partition here next to A, another partition here. So now my task is to know that whether B and B can partition further such that every component is a palindrome. So again I recursively call for B and B. So now let's say I put partition here. Okay. So now this B is also a palindrome. Okay. So after that, what will happen? I will again recursively call for this piece of string. So now this will again put a partition here, and once again we have received a palindromic partition. Okay. So finally, if I this is a palindrome, this is a palindrome, this is also a palindrome, and this is also a palindrome. So finally, I see that this part, everything is a palindrome. So at the same time, so once we reached here, we put this in a data structure. Once we reach here, we put this also in a data structure, this also in a data structure, and finally this also in a data structure. So finally, our answer would look something like this: A B, A A A B B, A B B. Okay, right? A B B. So this recursion tree is producing this answer. Okay. Now it may happen. Okay. So that let us see that let us come to here and okay. So this part of the recursion get called here. Now let's see. I'm calling. It means that let us. I'm calling this recursively function, but the thing is that I don't want to pick this element into my partition, so I have to go to the next element. But the string has become empty. So in that case, what will happen? I will again return back to this caller function. So I come here. Now I see that instead of partitioning it here, I want to partition it after B. So my partition would look something like this: AABB, right? So this is my partition. So now I see that this is also a palindrome, this is also a palindrome, and this is also a palindrome, and we have reached the end of our string. So this will give rise to our next set of answer, which will be AA, B, and B. Okay. Now I return back to this function. Okay, A, B, B. Now this returns back to here. Okay. Now basically what happens here? Now So this initially divided it here, but now it will try to divide it here. Okay. So basically, what will happen? Okay, there is a small mistake. There should only be single A here. Let me correct it. A B B. Okay. So now this function will try to recursively call for this part of the function, and it will try to partition in this manner such that A, B, and B. But I observe that this is not a palindrome. Okay, not a palindrome. So in that case, what will happen? This recursion tree will not get executed. Okay, because I only want to execute a recursion if I am able to get a palindromic partition. So now what will happen? It will try to put a partition here, but again then ABB is not a palindrome. So all these recursions will not get executed because I will only execute a recursion if I am able to get a palindromic partition. But I see that I could not get. So I will return back to the caller function. Now this will try to partition at this point. Okay. Next part. So A partition BB. Okay. So now it will send this part to the recursive function. Okay. Now once I get this part to the recursive function, there are two options. I can put a partition here. I can put a partition here. Or in fact, I can put a partition here and here. Okay. So since this is also palindrome, this is also palindrome, this is also palindrome, this is also palindrome, so it is correct. So this will be recursively called now, and since we have reached the empty string, it won't be recursively calling anything. Now this B will recursively call for only one options because B is only the last character. So finally we will have A, B, B. Okay. So this is a palindrome, this is palindrome, this is palindrome, this is palindrome, this is palindrome. So what is happening here is that this is our answer, this is our answer. So this will give rise to answer something like this: A, B, B, and this will give rise to answer A, B, B. So we see that our answer, this is the answer, this is the answer, this is one of our answer, this is one of our answer. So in total, we got 4 different ways we can actually partition this given string such that to generate all possible palindromic partitions. Okay, I hope this makes very clear to everyone out here. Okay, so Rishit is saying that can we try dividing remaining string at each point and check if it is substring is a palindrome? Yes, we are doing that. If the substring is a palindrome, then we divide the remaining string further. Else we try another partition point. Exactly, Rishit. This is the idea of recursion that we will be using. Okay, so I hope everyone one has understood this idea, this particular recursion tree. So can I please have a +1 in the chat? Those who are watching right now with me, I see there are 8 people currently live, but only few of them are interacting with me in the chat box. So I would request all of you all to kindly do a +1 so that I could get to know your names. Okay, please do a +1 if you all have able to understood this particular recursion tree. Okay, then let us continue. Yeah. So, meanwhile, those who have joined late, I would like to request you all to kindly do a +1. And apart from that, let me give a small introduction about this particular series that we are having. The name of the series is called Practice Session for SDE Interviews. And in case if you are preparing for your interviews, you would like to definitely attend this series. And at the same time, you can also check out our course called Complete Interview Preparation. The link is in the very first comment or it is pinned there. So it is an extremely well crafted course for anyone who is preparing for interviews. Okay. So I hope, yeah, let us continue then. So now I will be discussing the implementation and the logic of this code. So first of all, we have to devise a function. Okay. So let's say uh, we have a function in which we are given a string s. So that is basically the solve function. Okay. Okay. So let's say I have a solve function. We are given a string s. Okay. So now I have to create a function f which will accept, the first thing that it will accept is index. Okay. The next thing it should accept is a string s. After that, it should accept a vector called path. So this is a vector. Okay. And finally, we will also accept a vector of string called answer. Okay. So all these are passed by reference. Okay. So we have four things. The first is the index that we are starting from. S is the given string. Path is a vector in which we will store the valid path for every recursion tree that we are having, every recursion path. And once we have reached the end of the path and we have got a valid answer, we will store this path into our result. Okay. So initially we will call the function for f is equal to 0 comma s comma path vector and an answer vector, vector of vectors, a vector of vector of string type. Okay. So finally, what we can do basically is that, let us say we come inside this function. So first of all, we have to run a loop. Okay, why we are running a loop? Because and we will start from int I is equal to index. In whichever index we are presently standing, we will start from there, and we will go to the very end of the index. Okay, so it will be equal to s dot size. Okay, and finally we will do a I plus plus. So why we are running an index? We are running an index because we want to make sure that we want to partition at every point. So basically we are checking by partitioning at each and every particular point if that particular partition is leading to a palindrome partition or not. Okay. Okay, now we will check that whether, okay. So we will also write a function called isPalindrome, which will basically help to check whether a particular string is a palindrome or not. Okay, so now what we are doing basically, if it is a palindrome that the string has index and I, so I am checking that from index. This is index, and this is I. Okay, so I'm standing here on index. I'm putting a partition here. Okay, we are starting from here. So basically, I'm checking that every partition I'm putting whether this is an index or, palindrome or not, whether I am able to successfully put a partition or not. If it is a palindrome, then I will just push back it into my path. Okay. Okay, I know. I hope everyone understand how this sub-str function works. And finally, we will again recursively call this function, but now with I plus 1 because we have found the partition. But now, so my next index will be I plus 1, and all things will remain the same. Okay. Now, finally, what will happen here is that once we have reached the very end, okay, now I want to try every other recursion path. So what I will do, I will do a path dot pop back also. Okay. So once we are reaching the very end of recursion, the index will become equal to n. So if index is equal to n, which is the size of the string, in that case, what will I do? I will just push back into my answer. Okay, and what will I push back? I will push back my path, and then finally I will return also. Okay, so this is how this code will work. So can I please have a plus one in the chat if you are able to understood? I minus index plus 1 is length of the substring, right? Yes, exactly. I is the index that you are presently standing. Index is a starting point. And when you do I minus index plus 1, it's basically giving you the length of the string that you want to make a substring of. That you want to, that is basically a palindrome, and which you want to insert in your path. Okay. So yeah, so has everyone properly understood this? So index and I are both inclusive. No, wait, just a minute. Let me give you make you understand this properly. So index and I are both inclusive or not? Okay, let's see. Just a minute. Okay, so let us say that this was our problem was a b b. Okay, so initially you recursively called for this function when you are calling f of 0 comma s comma path and answer. So your index is equal to 0. Okay, index is equal to 0. So your loop is running from I equal to 0 to I equal to n minus 1. That is starting from here to here. Now what is happening here? You are trying to make check whether this is palindrome or not. S index is equal to 0 and I is also equal to 0. So 0 comma 0. So you're just trying to check whether A is palindrome or not. You see that yes, A is palindrome because A is a single character. It is a palindrome. So what you are doing now, you are recursively calling this function for one. Okay, the index plus 1 s comma path. Okay, so now index, you are standing here now recursively calling this. So now what is happening here, this part is a palindrome, which means that you have put a partition here. Once you have put a partition here, you are recursively calling for this part of the function. Okay, this part of the function. Now you have once this is a part, this is actually a palindrome, you will just push back into your path. Okay, what you will push back, you will push back A, just one A. Okay, and then recursively call for this. So now what is happening when you are just checking that the element you are pushing, so what exactly you are pushing, let me show it to you. You are pushing s dot sub str index. Index is equal to 0, I is also equal to 0, index is also equal to 0 plus 1. So 0 comma 1, it means that starting from index number 0, pick one character. This is the idea of sub str. Okay, this is the index and this is the I. Now once I will increase, let's say at the next iteration, suppose index is equal to this, and let's say we have A and A, something like this. At some point of time you will get that. So in that case what is happening, uh, this part I is equal to 1 but index is still equal to 0. Okay, so in that case what is happening, you are doing I minus index plus 1. So basically I minus index plus 1 is the count of the character starting from index number uh, index. So starting from this index, how many characters you want to consider in your palindromic partition. Okay, so got it. So I hope I was able to make you understand, Rishit, that how exactly are we having that particular idea of making a particular string palindrome. Okay, then that's great. So this was about palindromic partition. In fact, let me list out all the other important topics that are very necessary for recursion and backtracking point of view. Okay, so we have other topics which include recursion and backtracking are the n queens problem. There is something called as n queens problem, the Sudoku solving problem. Okay, and apart from that, we also have something called M coloring problem and rat in a maze problem. Okay, so all these four problems are very important for backtracking concept. Okay, so from next week onward, we will be starting BP. So I would request you all to kindly revise these problems because the concept of backtracking and recursion are extremely important if you are trying to understand how dynamic programming works. Okay, so this is from yeah. So let's keep our session till here only, and from next week onwards, we will be starting with recursion. Okay. So today will be a quite a short session because I wanted to keep a short session today. Okay. Because we are having the same thing from the previous 2 days as well. Okay. So Rishit, I hope it is clear. And all the other students, I would kindly request you all to kindly do a +1 in the chat box. And let me give a small introduction about the series. We are having a series called Practice Session for SDE Interviews. So if you're preparing for your interviews, and I would request you all to kindly attend these sessions because it will be extremely beneficial. We pick up topics every week and we discuss important concepts and problems related to those particular topics that are extremely helpful from interview point of view. And we also have a course called Complete Interview Preparation. And in case if you're preparing for your interviews, do check out that course, okay? Because it is an extremely well crafted course and you will be able to understand everything and make yourself interview ready. Okay. So yes, let's keep our session till here. Do you have any doubts? I'm here for a couple more minutes and then we can uh, wrap up our today's session. Any doubts? So, Rishit, will you? Thank you, Pranjal. So, Pranjal and Rishit, so are you guys will be having your interviews anytime soon, or are you preparing for your placements or internships? Which one it is? Yeah, so I see quite a lot of students have joined this particular session in this particular time. So I would request all of you all to kindly do +1 in the chat and like this streaming session as well, and subscribe to our channel, because this particular channel GFG Practice are planning to bring a lot of great quality content that will be extremely helpful for your preparation, for your interviews, for your internships, and for your placements. Okay, so I hope we are able to create a particular amount of value to you all, and so yeah, that's it. Let's meet up in the next session and see you there. Bye bye. Have a good night.